Traditional plug-in hybrids face a strict physical compromise. When the battery depletes, the combustion engine has to drag around hundreds of pounds of dead lithium. Conversely, in the city, the electric motor is forced to haul a heavy, dormant block of metal and cylinders. Engineers refer to this as the weight penalty. The vehicle is permanently burdened by the mass of two separate propulsion systems, creating a zero-sum trade-off between acceleration and electric range. The 2026 Mercedes-Benz S450e approaches this tension differently. It achieves a WLTP certified electric range of up to 115 kilometers, yet it still generates 435 horsepower and 680 newton-meters of combined system torque. To understand how those metrics fit into a vehicle of this scale, we have to look past the luxury exterior. This is a meticulously orchestrated dual-drive system that utilizes a P2 architecture to link internal combustion directly to battery electric power. Our investigation begins by mapping the hardware topology, followed by the software logic that governs the energy flow. The result is a bridging architecture, designed to transition the luxury consumer toward an electric future while preserving immediate usability and range. We start by stripping the vehicle down to a digital chassis to trace the power delivery. Looking at this technical specification sheet, we find the primary internal combustion engine in the S450e column, an M256 Evo inline 6 with a 2,999 cc displacement. By itself, this combustion engine produces 299 horsepower, or 220 kilowatts, peaking at 5,500 RPM. The electric component is a 150 horsepower synchronous motor. Its physical placement is the defining characteristic of this drivetrain. In a P2 architecture, the electric motor is integrated directly in line, positioned exactly between the combustion engine and the 9G-tronic transmission. Returning to the spec sheet, the torque output row shows this electric motor alone contributes an instant 440 newton-meters. Because of its inline position, every unit of energy, whether derived from gasoline, the battery, or both simultaneously, routes through the same 9-speed gearbox to the rear axle. This routing gives the electric motor a distinct mechanical advantage, allowing it to leverage the transmission's gear ratios to maximize efficiency across various speeds. As the table indicates, the India spec S450e relies strictly on a rear-wheel drive configuration, omitting the 4MATIC system found on models like the S580e. The P2 architecture essentially turns the synchronous motor into a force multiplier for the combustion engine, unifying their output. To sustain that electric force, we have to move to the rear of the vehicle, where the energy is stored. This technical data table outlines the battery specifications. The S450e utilizes a 22 kilowatt-hour lithium-ion pack, enabling that 115-kilometer range. At 22 kilowatt-hours, this capacity rivals the batteries found in early, fully electric city cars, far exceeding the typical storage of an average plug-in hybrid. But density has physical limits. This weights and capacities chart shows the direct packaging consequence. Boot capacity shrinks to 350 liters. Compared to the standard S500, which offers 550 liters, the battery pack claims exactly 200 liters of cargo volume. To offset the larger battery, Mercedes integrated rapid charging. The table lists a 60 kilowatt DC fast charging capability, pushing the battery from 10 to 80% in 20 minutes. For home use, an 11 kilowatt AC wall box restores full charge in 2 hours and 15 minutes. On the move, the S450e relies on radar-based recuperation. The car's forward-facing radar telemetry detects slower traffic ahead, automatically increasing the electric motor's regenerative braking force to harvest kinetic energy while matching the flow of traffic. The combination of a high-capacity battery and DC fast charging allows this sedan to complete the majority of urban duty cycles entirely on electric power. Hardware provides the physical potential, but software orchestrates the delivery. Turbocharged engines suffer a physical delay. Exhaust gases take time to spool, leaving a torque deficit during initial acceleration.
Software recognizes this gap, signaling the electric motor to execute an instant torque fill of 440 newton-meters, flattening the curve. The system also features an over-torque function, permitting deliberate, momentary torque spikes when the driver demands rapid overtaking power. This performance data sheet confirms the result. Despite a curb weight of 2,645 kilograms, it achieved a 0 to 62 sprint in 5.9 seconds. Top speed is electronically limited to 155 miles per hour. Managing nearly 2.7 tons at speed requires precise dynamic control. The vehicle employs standard airmatic air suspension, adjusting the dampening force at each independent wheel to mask the significant weight transfer during cornering. This is paired with standard rear axle steering, capable of up to 4.5 degrees of lock, virtually shortening the wheelbase to improve agility. The software merges two disparate power profiles into a single combined 680 Newton-meters of torque, mimicking the linear response of a naturally aspirated engine. The driver interacts with this complex powertrain by selecting specific operating states, or drive modes. In electric mode, the system prioritizes the battery. To prevent the combustion engine from waking up accidentally, engineers added a haptic accelerator pedal. The pedal features a physical pressure point. Pushing past this distinct barrier under your foot signals the computer to instantly ignite the combustion engine. Hybrid mode is the default balancer. The software continuously evaluates navigation data, speed, and battery state to deploy the most efficient mix of gasoline and electricity. Battery hold mode overrides this optimization. It deliberately locks the current battery percentage, freezing the state of charge for future use. This allows a driver to use the combustion engine on a high-speed highway stretch, reserving the stored electricity to navigate a zero-emission city center in complete silence later in the trip. In sport mode, efficiency takes a backseat. The 3.0-liter straight six remains continuously active, ensuring maximum system output is available instantly. Individual mode decouples the powertrain logic from the chassis, allowing a driver to combine a sporty steering and suspension setup with the quiet efficiency of electric drive. Throughout these modes, an Eco Assist system monitors road topography and speed limits, prompting the driver to lift off the accelerator early to maximize energy regeneration. By offering these distinct states, the S450e operates as a powertrain-agnostic vehicle, adapting its physical behavior to the specific mission of the drive. The S450e arrives as a distinct milestone for the Indian market, serving as the first S-Class plug-in hybrid. It achieves this by mating the M256 inline-6 engine with an inline P2 synchronous motor. Together, they deliver a combined output of 435 horsepower and 680 Newton-meters of torque. Yet the 115 kilometers of electric range means a user can manage an entire day of city driving without engaging the fuel injectors. This substantial electric buffer effectively eliminates range anxiety, removing the primary friction point for buyers considering an electric vehicle. Entering the market at 2.20 crore rupees, it establishes a premium entry point for tech-focused luxury buyers. Ultimately, this architecture bridges a critical gap, acclimating traditional luxury consumers to silent electric propulsion before they transition fully to battery electric platforms like the EQS. By scaling the battery and refining software arbitration, Mercedes has mitigated the inherent weight penalty of the hybrid powertrain, providing a usable electric range that covers the majority of daily urban travel. This iteration of the S-Class uses over 2,700 new or revised components to integrate this dual-drive hardware into the long wheelbase chassis. Historically, the S-Class debuts the technology that eventually standardizes across the industry. The S450e proves that for the next decade, the best car in the world will be one that masters the integration of both electrons and atoms.